started my amendment.
Speaking of patience, you guys want to try to rush through this?
Yeah.
Okay. Awesome.
Might be fun.
All right, let's take a look at this.
This one's going to take SPSS, which I finally bought.
Yes, it took that. Okay, let's see. Okay. Let me know when you guys are ready.
I'm ready.
I'm ready.
Okay. 11, part 2. There's a lot of parts to part 2. Okay. Okay, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients, purchases an investment property, and obtains the data shown. Blah, blah. What are the requirements for creating 95% confidence T-interval?
So I think we just kind of get like what the actual things are, not like any type of number value then, right? So in order to get a T-score, we know the standard deviation.
Okay.
There you go.
So it needs to be a simple random sample, and it either needs to be normally distributed population or n needs to be greater than 30. And our n is 15, but it does say that it's normally distributed, right?
Mm-hmm.
And it is a simple random sample, so that qualifies, right?
Yeah, because it either has to be A or B with either of these conditions are satisfied.
Yeah. So we got it. So we can definitely get a T-score. Yay. Okay. So moving on to number 2. I checked it. That's all that they wanted from us.
What all did they want again?
That's all they wanted. Listing that it needed to meet the qualifications that it's a simple random sample, and that it's either normally distributed or the n's greater than 30. And this one in particular met the normally distributed.
Okay. Okay. Okay, so for 2, the data above create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show the work below. T-score for a 95% confidence interval from the T-distribution with 14 degrees of freedom is 2.1448. Make sure you do not overround while making your calculations. Okay.
Okay, well, I'm going to start listing the SPSS again. So we got 27.
You want us to read them off to you?
Hang on, I have to figure out how to use this thing again. It's not like
Maybe this one. What?
I bought it, but I still don't know how to use it.
What dog? Right here. Oh, with me. Oh, yes, we're cuddling. Sorry, me and the dog. Yes. Sorry about that. They're looking for the dog. Okay.
So I just need to figure out where it's going to let me write it down. 27? Right. It's not like Excel where you can just like write wherever you want.
I know that it's so I don't. Yeah, I can't ever get that to work.
Okay, so
I feel like this is going to take a long time.
Can anyone meet at another time this week? Can anybody meet tomorrow night?
I can meet tomorrow night.
I could, but I might be really late. That's the only thing is I wouldn't be able to meet till probably 9 if I met tomorrow night.
Mm.
But if you guys wanted to call it, I could just try to do this on my own.
See?
Well, it's not fair. Plus, we enjoy you reading everything.
I know. Sorry, it's such a spoil to us.
Someone could try to imitate my voice and read it.
That'd be funny to listen to later.
Maybe like Gollum from Lord of the Rings, you know. Just have a multiple conversations. Okay. Well,
I'm still trying to figure out how just to exit out of SPS. Closing the last data editor window will exit this. Do you want to proceed? Yes. But then nothing happens. No. No.
are we able to take a look at the quiz and then if it looks like it's going to be like really difficult, pause it and then continue it later?
I think we can.
Yeah, if you log out, it'll...
Yeah, I was gonna say you have to like you can't like save to continue. You'd have to like exit out.
I'm pretty sure that no matter
there's a save for a later option.
There is?
It's 15 questions. 1, 4, 5, 6. And 6 of them require us to fill in a number.
Okay, so I'm gonna try this again.
Not bad.
You guys want to try doing the quiz, and then if we get to a point where we get stumped, we can save it for later or something? I mean...
I'm okay with
I think that no matter what we do, though, we're gonna need.
We're going to need to know what we're doing. With the...
Well, no, we're gonna need this program because in order to do teach
Oh, got it.
have it, so I'm still just trying to figure out how to input data. I have no problem doing it that way. I just need to be able to enter.
Gotcha.
So, okay, good. I started entering things. Cool. Hopefully this works. Minimize that. Okay, so I'm gonna really quickly get into the in the book reading. Did you guys see if it gives the commands to making these charts?
No, it does. Well, I didn't do their book reading. I just did the...
Because we have to know how to get the charts that they get in SPSS. And I don't know, even if I put the data in, how to Excel instructions. Okay, that's for Excel. SPSS instructions. Okay.
Oh yeah, okay.
I got it. So we can try this. Cool. So I got put in the screen. So we're gonna go ahead and start the quiz then. Is that what you guys want to do?
Yeah, let's take a look at it, and if it's just too ridiculous, then...
Are we taking the quiz?
Did you say that there was instructions on the new graphs in the reading?
Yeah, I
Yeah.
have.
Okay.
It's under step 4.
Okay.
Okay.
Okay. So you want to read number 3 for us, Matt?
Sure. Let's take a
Whoa.
look. Okay, 3. In previous lessons, we have assumed the population standard deviation of sigma was known. In this lesson, we are making a different assumption about sigma. What has changed? We assume sigma is unknown, correct? Okay. The null hypothesis of mu equals 8, and the alternative hypothesis of mu is greater than 8, and its population standard deviation of sigma is not known. Becca collects a sample size n equals 9 and computes that x bar equals 11 and s equals 6. Is sigma known?
So how did she figure out S without knowing her sigma? I don't even know how you would calculate for S. S is something you use when you don't know sigma. Right? That's good. Is that what you got out of the notes?
Well, s is the sample statistic for the standard deviation.
But S only comes up for the same statistic when you don't know. Like in all of my notes, it's always something unknown. So like.
So S, you use S for your sample standard deviation.
Yeah, because you don't know what you don't know what sigma is. So for number 4, I would say no. Right? Because if you knew what sigma was, you wouldn't be calculating for S.
Well, doesn't it say that it says that the standard deviation is not known? Or sigma or whatever.
Yeah, it does.
So is that supposed to be a given?
I guess. I don't know. It says it, so I don't know why. I think maybe that was like a trick in me, but.
And I'm looking through everything else, and like all of my notes, the S issue always comes up in all of my how to figure out the t-score for an unknown sigma. So
Yeah.
but since we have all the data, since she solved for that, we can go ahead and do the math.
What's the equation that we're looking at?
T equals x bar minus the mu or the mean of the null hypothesis, so it's like mu 0, or just
Okay.
mu, all over S over the square root of n.
So z equals x bar minus mu all over s over the square root of n.
Close. T as in Tommy Boy equals x
T.
bar.
Gotcha. Okay.
So we don't know anything about T. That's kind of different.
Okay.
So T equals 11 minus.
Me?
Over.
So I got 3 over 2. Is that what everybody else got?
Yep. Equals t. So it's 1.5.
Yep.
Sorry, what'd you guys get?
1.5.
3 over 2.
And how does t help us for 4? What do we know about sigma? So is sigma known or not? It's still not known?
Hang on.
Okay, just to clarify, what equation did you guys type in?
So it's T equals x bar minus mu 0 all over S divided by the square root of n.
So
Yeah.
I got T equals 1.5.
That's what I got.
Okay, so then Okay, weird. Can you guys read me the numbers you guys actually, like the numbers and everything?
11 minus 8 all over 6 over the square root of 9.
Yeah.
So
Weird.
3 over 2.
Because the square root of 9 is 3, 6 over 3 is 2, 11 minus 8 is 3, so it'll all be 3 over.
Oh, okay. I got it. I got it. Thanks.
No problem. So we did it. Yay.
Yay. Okay. Um. Well, the next part is what involves us. Did we know if sigma is known? Sigma is not known, correct?
For the next
For
part?
question before. For 4?
No, we
No.
put no.
No. Sorry, I completely missed that. So for 6, what is it, 6, 7, 8, 9, or something like that?
Yeah.
6, 7, 8, 9, 10. All requires SPSS.
And then looks like 11.
11 through 15 do too.
Well, I have SPSS up. So do we want to try it?
Yeah.
Because once you put it all into SPSS, SPSS will give us all the answers that we need.
Yep.
Okay.
So I'm going to put these in.
Do you want us to read them off to you, or can you copy paste it in?
I'm going to try to copy paste. I copy pasted.
It worked.
So I have all of them in, so now I have to read the instructions. So
Okay, I can read that to you.
I have to go to Analyze.
Analyze, and from Analyze you go to,
Compare me.
yeah,
And then one sample t-test, is that right?
1, and then sample t-test. Yep.
Do I need to do options or anything?
No.
Let's see. So our mean is 98.22. Our standard deviation is 0.92201. Our t-score is 476 point. What do you guys need?
So what is X bar?
For
So,
sample mean. So the mean is 98.22.
okay. What is
So
S?
that's the answer to 6, right?
Yeah, 98.22.
S is the standard deviation. So what is that?
Hang on. The standard deviation is 0.922.
And then the t-score?
Hang on. I don't really
Okay.
understand the t-score exactly because it seems kind of crazy, but it says 476.407. I don't know how. Oh, I think you're supposed to plug the t-score into
No,
the.
aren't you supposed to?
You
'Cause I
divide.
remember
You divide the DF in half. But
yeah, I remember you have to divide something by 2.
Yeah, that's the DF. The what does that stand for again? The degree of freedom you divide in half.
Freedom.
It's
Okay.
Degree of freedom.
anything other than different. Because this calculates for both ends. So if it's just a
Right.
one side, you have to divide it by 2 to get just one side. But the t-score is 476.407, which, I mean, I've used all the data, like all that's in there. That's what it's giving me. I just don't really understand how it got that. Okay, so is that what you guys want to put in? That's what it says.
Sure, why not?
So 476.
0.407.
Yeah.
And what is the p-value?
We have to plug it into the applet.
Gotcha.
I don't really remember how we plugged it into the applet, but that seems like a really large number.
Yeah, I don't know if that would work in the applet.
Because it seems like the applet's equal to 1.
It is. Usually. That's what it seems like.
So what is the, let's see, if t is large enough, SPSS will give the value of sig two-tailed as 0.000. So what does the sig two-tailed show you?
What? Oh, the zig two-tailed is just 0, 0, 0. So we just put close enough to 0, close to 0.
You would put 0.0000005 and then put it in half. You need to find a p-value for a one-sided test, and this number should be divided by 2 and reported as, okay.
I don't understand how the t-score is so high, though.
0.005, right?
For which one?
Okay, for p-value, like I'm trying to understand reading the lesson here.
I just don't understand how you're getting the 5, because the only information it gets me is a 000.
Yeah, so I'm reading the notes on how to do that. At the end, it talks about if the t value is large enough, SPSS gives the value of sig two-tailed as 0.000. By double-clicking twice on this cell, SPSS will display more digits. If t is very large, then you click on this cell, SPS may show a value of 0.0000000. Like the normal curve, the t-curve never touches the horizontal axis, so there's always a little bit of area in the tails, no matter how far out you go. If SPS gives you a value of 0.00000, report the area as
So
0.00005.
the actual value is 3.3349 e to the negative 40, in case you guys wanted to know.
For the T?
No, the sig two-tailed.
Oh.
So how do they want us to report it then, Matt? Just 0? Because it
Well,
says round of 5.
Well, see, it tells us to go 7 decimal places, but here the answer we're supposed to give is only
3.
3. So is it 0.000?
That's what I would assume.
I feel like it's
0.000?
0.000. Which
that's
is,
something that would make sense.
but it's so much smaller than what the alpha thing is that we would have to reject the null hypothesis. Like, I don't know, that t-score is just so crazy. I wish somebody else had done it too, so that I didn't feel crazy. Literally, I just copy and pasted all the information and then clicked on that column. So I don't know how I could have done it wrong.
Well, most p-values are going to equal some number times 10 to the negative umpteenth number, you know, which is going to be like 0.00000, blah, blah, blah. Gosh. So I don't know if we round it up to like 0.001, or like what we're supposed to do. Because it's so many zeros away that 0.000 would be the only answer, I think.
Well, if we're only doing 3 decimal places and the actual p-value is to the negative 40th exponential power, I'm just going to put 3 zeros and call it good.
Yeah, me too. I think you're right.
We would have to reject the null hypothesis because that's just so much smaller.
Yeah, it is.
And then we'd have to do this whole thing again with a new value. So I'm going to copy and paste all of this stuff, right?
Yep.
Okay. For 10, we reject, correct?
Yes.
Okay, so now we're doing the next set of numbers.
Yeah, and I just copy and pasted them.
So what is the p-value for this next one? So what's the sig two-tailed or whatever?
Hang on, I'm still loading it.
No,
So
you're fine.
two-tailed is another 000. And when I double click on it, it gives me 0.00. Hang on. 1, 2, 3. There's 4 zeros and it's 62. That makes me so mad that it's it's like right there. I can actually see this one, and we're still just going to end up putting 000.
Because that's the t, and you take that over 2 to give you the p-value, right? 0.00031 would
Well,
be the p-value.
the p-value, you calculate the t-score and then determine.
Or is this for a two-sided test that could be different?
Well, that you're looking at the degree of freedom. So to determine the p-value, I just wrote down use the applet. Oh, hang on. How did I plug this into the applet? So I think I have to take the t-score. The t-score was 5.048. So if I plug that into the applet, 5.048. And then what area do we do? Is it the front of it, the middle?
Which score are we talking about?
The t-score.
But for the normal probability applet, that's for the z-score, correct?
Yeah, but in my notes it says to use the applet to figure out what the p-value is. Justin.
Yeah, I put that in my notes as well.
Is there a way to
I'm just
convert
trying
the
to figure
t-score to
out.
figure out the z-score?
Well, don't you have the standard deviation and everything?
Yeah.
Can't we just do it manually? Are you still looking for the t-value?
I guess that now that I have everything, we don't have to go through the t-value. The standard deviation is 36.35585, and the mean is 40.0476.
What was the standard deviation? 32.3585?
Standard deviation is 36.
Oh, 36.
0.356. That's how it works.
Okay.
And then the mean is 40.048.
Okay. I'm sorry, did you figure out, what did you say last?
We decided that since I have all the other information, maybe we should just try to solve for the z-score.
Okay.
Or you can even, yeah.
I feel like there's another applet that we're supposed to be using. Not the normal probability one, but the t demonstration.
Well, if you look,
It said use the normal.
yeah, and if you look in the notes, what does it say in the textbook?
Because I have written down determine the p-value based on the test statistic. Use the applet.
So I'm supposed to select both sides of what's shaded in green. So let me try that again. So my t-score was 5.048. .048. So it's 4.464 e to the negative 7. Which means it's really little. Which means we reject the null hypothesis again. Ugh.
So what did we put down for 11?
I put 3 zeros again because the actual
Okay.
answer was 4 zeros and then 62.
Okay.
So we reject the null hypothesis. Why couldn't she just do one of each so we felt good about ourselves?
No.
Decided to try another alternative hypothesis. This time you use that, and you keep the same levels of intense. That would mean it would be one-sided. So I would take one of these little dudes off. It's like impossible because you can't really click on anything. So
So
what
the
did it?
probability would decrease if it was one-sided. Does that make sense?
Yeah, that's what I'd think.
It would decrease because you got half the chance. So the p-value here should be smaller. It's one tail, not two. I think.
Yeah.
Just like looking at it, you know.
Yeah, definitely.
14. What decision do you make? Well, there's a chance to decrease was before with an even smaller p-value, rejected again, right?
Yeah.
15. Compare the width of the confidence interval for question 11 to 13, which is wider. The wider confidence interval should be 11, right?
Yeah, because it's two-sided.
That's what I would think. You got a greater chance.
What I was thinking. You guys feel the same?
I think. At
Oh,
this
yeah.
point, though, I'm pretty tired.
Yeah.
I'll be honest.
I think I'm going to submit.
Okay, me too. Take the bullet.
Oh, ouch.
Ouch. We didn't fail. We got our first 5, 6, 7 correct. The t-score and the p-value, no. 10.
It doesn't make any sense. Like when you plug in this stuff, how can you get half the data right and then the t-score is just totally wrong?
Yeah, that makes no sense at all.
I
How
think
is it failed?
I'm going to email her.
Yeah, I would do that too. Okay. Well, we'll give it a good shot, I guess.
Well, at least
Alright.
we're done.
Yeah, we can wash our hands of it.
Yeah, I need to go sleep here so loud. So I'll talk to you guys later.
Yeah.
Bye, guys. Bye.
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 The
Yeah.
This.